Okay guys, welcome to machine learning tutorial, and in this video we're going to talk about convolutional neural networks. So what exactly the convolutional neural network is? Basically it is used for the image and picture recognition. So it actually analyze the pixels, right? So to understand a convolutional neural network, let's move to the simple world. So in a simple world, we have a person and a computer. So in a computer, we have a 2 pixels by 2 pixels screen, and we have a keyboard, right? So in a keyboard, we have two letters, and basically of which the alphabets are made, right? And those are the backslash and the forward slash. You might have played a game of the Scribble, right? It uses a backslash and a forward slash. So it's like the all alphabets are generally fundamentally made of the backslash and the forward slash. So let's say that we have a computer screen of 2 by 2 pixels, and when we click or basically when we push the button, the basically backward slash button on keyboard, we have a visualization like this, and we have a visualization for the forward slash is just like this. So it's basically a visualization in a computer. That's how so basically we have a different visualization for different. So let's see how we see actually the backslash and the forward slash. So we see in the numbers like 1 minus 1. So but the problem is that computer sees in a very different way, right? So the computer sees in a different way. It sees in a rectangular or more like a linear. So how can we differentiate the backslash and the forward slash in a computer? So basically we have to basically teach the computer how to set apart these symbols, right? So that we can make the alphabets in a very logical way in a computer. So what are the operators we can apply so that we can have different results for each of these slash as shown in a line uh, in the right? So what we can do, what if we add the above numbers in a strip, right? So let's just say add 1 plus minus 1 plus minus 1 plus 1, which is equal to 0, and that's similarly for the second strip as well. But the problem is that we have to set them apart by having different results so that we can differentiate both the backslash and forward slash. Okay, let's try another operators like multiplication. So what if we multiply both the, or basically all the ones we have? So we have 1 multiply minus 1 multiply minus 1 multiply 1, which is equals to 1. So for the next strip we have the same result as the above. So that's also not a good option to differentiate these two strips for the differentiation of backslash and forward slash. So just feel free to pause the video and just think what are the conditions so that we can apply operators to get the different results, so that we can easily differentiate both the strips which is read by computer. Okay, so let's just evaluate the first strip. We have plus 1, then minus minus plus 1, minus minus plus 1, plus 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 1. So we have the result equal to 4. So for the same second step, we have plus minus 1 is 1, minus plus minus, and minus plus minus minus 1, and plus minus minus 1. Sorry for the wrong interpretation. So what we have is the same result, the different result, right? We have plus 4 and minus 4. So it seems like this is the best way of putting operators in between the 1 and minus 1. So this is how we separate backslash and a forward slash and teach this thing to the computer. So what we just made is a image recognition classifier. So this is how we will going to classify the backslash and the forward slash as shown in the picture, like plus, minus, minus, plus. Okay, now look at these images. What it does look like. So to me, the above one is look like the poorly drawn backslash. So let's talk about the bottom one. So in the bottom one, it seems like the slash is made up of half. It's made basically half, uh, and it is actually a forward slash, which is half actually, right? So this is what I interpret from this. So let's see what the computer sees. So it sees this 1 1 minus 1 1, and in the bottom it sees minus 1 minus 1 1 minus 1. And if we use our existing classifier, what do we get? We get plus minus minus plus, right? Now if we apply these signs to our the strip, we will get plus plus 1, then minus 1, plus 1, then plus 1, then so we're gonna get plus, and for the bottom one we get minus 1, plus 1, minus 1, minus 1. So the result will be minus 2. So that's pretty good, because computer will going to understand that the this is a wrong or incorrectly drawn backslash or forward slash. So we want the system, but the question is that how the computer will going to recognize, right? But because the good thing about humans is that we have a vision which is efficiently worked from the ancient times, right? So basically we can easily tell whether it is a backslash or a forward slash, but computer can't think that way, the way we think. So what can a computer can do? What I think is that computer can do many things quickly, right? So computer will going to check each and every symbol on the keyboard and all the pixels for which is possibly can be occur, right? So these are the basically the pixels to which computer can look to and check them all, and it seems like that all of them worked improperly, and two of them worked pretty well, and that's it. So what the computer had is 16 choices, but the problem is that it's not about 16 choices. The world we live in has so many choices to handle, so computer cannot do it efficiently. So what we need is that we want the computer to do some very complex calculations, which is quite humongous. So we have to find some smart way. So computer has to form a new criteria, and that's it has to start from random pixels. So the one we start is basically the addition of all the numbers. We saw that that didn't work correctly, because it didn't separate the slashes, right? So it worked so. Okay, but let's make some small changes to that. Let's try to change each plus to minus. Okay, the first one did worse, then second one did better, then worse, then last one did better. So let's say the what about second pixel. The second pixel did worse first and then better, and then it got also worse. So let's choose the better one. So but in reality we are restricted to very small numbers, right? We cannot use 100, 2000, 600, 6000. So we are restricted in decimals, right? So this is how we can visualize our classifiers for forward backslash and the backward backslash, so that we can make our alphabets in the form of classifiers, which is shown in right, that is X and O. But the question is that how to create a classifier which sets these letters apart. Well, we can start in this in a same way as we have done before, putting some pluses and minus. But we will gonna quickly notice that this is going to start failing, because it misses the point in the letter or the image, right? In reality, this is not what we. Okay, so let's look at some previous knowledge. What we have learned from the simple world. What we have learned is that this is a backward slash, and then this is a forward slash. So let's use that to break our further pictures. So what we have is this X, our O, our forward slash, our backward slash. These are basically the diagonals. So what we're gonna do, we're going to break them apart into a simple pieces. So X look like this combination, and O looks like this, and forward slash looks like this kind of combination of diagonals, and backward slash look like this. Then we are going to take another step and turn this into X, O, forward slash, and backward slash. Okay, so the first part what we have done is that it's a combination of convolution layer plus pooling layer. So, and the second one is called fully connected layer. So basically convolution layer break the pictures into the smaller pieces, and then what fully connected layer do is that it actually combines all the break pieces and make some logical letters, alphabets more specifically. Okay, let's do this in detail. So here we have 3 by 3 our uh, pixel image, and the two 2 by 2 pixels boxes beside it, the arrows are basically the filters. Okay, the one filter is for the backward diagonal, and the second one is for the forward diagonal. So what we're gonna do is we will going to merge these filters on our pixel, which is 3 by 3 pixel we have, and check whether we will going to check whether what was the result we will find. Okay, so let's merge the filter on a pixel, and let's say we have a plus one, minus minus plus one, minus minus plus one, and plus one. So we have 4. That means if we've found a big number, then we actually find the piece we were actually looking for. So basically this filter is the piece of the diagonal. Okay, now we move here and do the same thing. So what we're gonna do is we will get is plus minus minus 1, uh, then minus 1, and then minus 1, and then plus minus minus 1. So what we're gonna have is minus 4. So in this case we actually didn't find anything because the number is too small. So again we move to the bottom left. We check again, and that's plus minus 1, minus 1, minus 1 and then plus minus 1, which we have, what we have is minus 4. So again we didn't find anything because the number is again too small. So the next layer actually says the number is too small, we don't find anything. So and the last one says we get a plus 4, so we find the piece actually to what, to which we are looking for. Okay, let's use the other filter. So this filter will going to find the forward diagonals. So we again put it here and we perform the operation minus plus 1, so we get the result minus 4. So the next one says I didn't find anything because too small. So we go to another one and we get 4. So we did find actually something, and that is says again we find the forward diagonal, but when we go again to check for the last one, we haven't find anything. So the left part is called the convolution layer, that takes the filter and slides it through the image and finds whether we get our valid piece of pixel or not. So pooling layer basically checks the threshold, that if the threshold is sufficient or fully, if the threshold is satisfied, then it will going to find a number, or basically the diagonal for the image. So finally what we will going to do is that we will going to superimpose both the images at the right, and we find this like this. So now computer will look this image in the right, because we actually simplifies the image using forward and backward diagonal filters. So similarly for O and forward backslash and reverse backslash, we're going to find the fully connected layer similarly as we have done for our for our fully connected layer like X. Okay, let's just summarize three things: the convolution layer, the pooling layer, and the fully connected layer. So what we have four our pixel images of 3 by 3, and now this is the way the computer sees now after the convolution and pooling layer, right? But let's summarize that the computer do not look like the way we see. It looks like in this way, in the form of string: backward diagonal, forward diagonal, and backward diagonal. And then for O, similarly, like the forward diagonal, backward diagonal, forward diagonal. So the computer reads the forward diagonal as first the blank, then forward diagonal, and then blank. And similarly for the backward diagonal, backslash, sorry, is for that, like backward diagonal, blank, blank, and then backward diagonal. Okay, let's just first encode these as the matrix, so that to know where we're going to find the forward diagonals and where we're going to find the backward diagonals. Okay, let's look at the backward diagonal and just compare it with every string that we have, that whether we have it or not in the string. In the first position we have it, and in the second position we don't have it, and in the third position we also don't have it, and in the last we have it. So what we're going to do is just, okay, now let's try with the other diagonal, the uh, the forward diagonal. So the first position we have not the same, and the second one it is the same, and the third one it has the same, and the last one it has not. So we are going to put -1 in the last one. So what we have done is we transformed the string into a matrix. So similarly, we can do for the next one uh, in the same way. So feel free to pause the video and do it yourself. So the second one become this, and the third one is like this, and the last one is like this. So what we have done is that we have convert, or if you can say that we have transformed the fully formed pixels into matrices. Now we have to create filters. So what we're gonna do, we will going to compare each matrix with each filters we have, like this. So we will going to do this in the same way that we have done before. We will going to basically put the signs with each of the matrix. So what we are going to get is that we have encoded first filter to X, and the second filter to O, and the third filter to forward backslash, and the fourth filter is for reverse backslash. So if we merge the first filter to the matrix, we'll get +1, then minus minus +1, then minus minus +1, then +1 +1, then minus minus +1, then +1 +1, and then last one +1. We're going to add these numbers, so we get the score of 8. So what happens when we do this for the second one? So we get the result -8 if you do it yourself. Then for the third one we will get 4, and for the last one we also get 4. So what we have to do is just pick the number from the right, which is basically the highest actually. So the winner is 8. So it turns out this is the winner. So what we conclude is that our 3 by 3 pixel is basically the X. So if you do for the O 4, and the last one gave you -4, so second basically wins. So we conclude this as O. So similarly for the third, that is the forward backslash, we get the 8. The third one wins. So for the backward, so this is basically the backward diagonal. So what we had is our 3 by 3 pixel, and we have applied 8 filters. Each pixel has been applied 2 filters. That means we have total filters which is equal to 8. So this is what we call convolutional layer. And whenever we get something like large number, then the pooling layer says you got something. So this is the pooling layer actually. So after a pooling layer, the things become like this kind of matrix. Your pixelating image doesn't look like more like pixelating images, so it looks like a matrix. And the last layer does is that it connects or basically merge each of the filters to each of the matrix to get the fully connected layer. So that's why this is called the fully connected layer. So it basically allows to distinguish between the highest score and the other scores. The highest score wins. So the computer, that's how analyze that uh, that this is X, this is O, this is forward backslash, and this is backward backslash. But the problem is that it took so much time for us to analyze the results like of alphabets. But the problem with the computer is that it actually works in a different way. So how the computer analyze this kind of mathematics is basically how we have done this before, and that's a gradient descent. So it starts with a random number, for the convolution layer, for the everything. And of course it has lots of errors, so to decrease the errors, gradient descent work and minimize those errors using activation functions and with the help of error function while finding the derivative. Okay, so this is how the computer did. So if you really like the video, please like the video and share it or comment it, or if you really do have any problem, please share with me. I'm all active. And otherwise, thank you for watching. And in the next video we're gonna talk about the recurrent neural networks, so stay tuned.